Alright, so today we are going to discuss the new chapter, that is differential equations. Okay? Can anybody tell me, can anybody has any idea about differential equations? What it could be? Any answers? See, I would like to make an announcement, like this chapter is very important for CBSE also. Okay? For 12th board it is very important, as well as for JEE. So any volunteers who would like to give the answer? Come on. Equation more than one derivative. Equation more than one derivative. No. Anybody else would like to try it? What do you mean by differential equations? Separating dx and dy. No, not like that. Okay, I'll tell you. See. First of all, you tell me, what is an equation? What is an equation? What do you call something which is an equation? See, any algebraic term is there. If suppose there is any algebraic term, suppose x plus t. So right now this is what? This is an algebraic expression, okay? And if you put an equal to sign into an algebraic expression, then it will become, for example, let's take it as equals to 0. So now this whole has become an equation, okay? So this is equation. This is now equation. So equation is having x as its variable. In this equation, what we are having as variable, it is x. So similarly, the same concept is for differential equations. If any equation is there whose variable is a differential element. Now what do you mean by differential element? For example, dy by dx is there. Or example, dx by dy is there. So this will be as a subject. Okay. For example, just say dy by dx whole square plus 5 dy by dx plus 6 is equals to 0. Now this is a differential equation. This is a differential equation. Why? Because first we can see that, so this is an equation, and rather of having x, we are not having x as the main variable. Rather we are having differential elements as the main variable. Okay, it could be dy by dx also, it could be dx by dy also, it could be second order derivative d2y by dx2 also, the ones that we studied in the higher order derivative. It could be dx2 upon dy2, d2x upon dy2. Sorry. This is something which we call as differential equation. Am I clear, everybody? Am I clear on this? Quickly tell me so that we can proceed. Okay, fine. See, now these are some examples of differential elements. Differential equations, sorry. Like d2y by dx2 plus 3 times dy by dx plus 2y is equals to 0. See, you can have x and y also. X and y can also be included. X and y can also be included. But the main variable is differential element. For example, here we are having d2y by dx2 plus 3 times dy by dx plus 2y. And more than one differential element can also be there. For example, dy by dx and d2y by dx2. Both can occur in same differential equation. So these are certain key points. All right. So please, these are the some examples of differential equations. So please note down. d2y by dx2 plus 3 dy by dx plus 2y is equals to 0. Second one is d2y by dx2 is equals to y plus dy by dx 6 whole power 1 by 4. All right, I'm sure the idea is clear. Okay. Now the very first thing that we are going to study in this differential equation is order and degree of our differential equation. Order and degree of our differential equation. Okay? So pay very much attention over here, because this is a question which can be appear in JEE also, but it is a mandatory question in CBSE. Okay? So what do you mean by order? So as the definition says, order is the highest differential appearing in a differential equation. That means, like, you know that in a differential equation, what will be the main variable? The main variable will always be a differential element, right? So it could be dy by dx, it could be d2y by dx, it could be d3y by dx cube. So what is the order of that differential element will be the order of that differential equation. For example, if I just ask you d2y by dx2, so can you please tell me what is this order? This is second order. Yes, d2y by dx2, if I'm talking about d2y by dx2, then it is second order. So if this is the main variable, so that means the equation will have the order as its 2. Okay, so it will be more clear. It will be very much clear when we see the questions. But first you have to learn the basic concept. So d2y by dx2 is the if d2y by dx2 is the differential element being used in a differential equation, then it is called as second order, or we can say the order is 2. And now what is degree? So degree is the highest power of that highest differential. But see, yeah, hi Parikshit, good evening. Okay, so we're talking about this degree. So degree is the highest power of that differential element. But there is one rule. Like, you cannot tell me degree before solving it. So for example, if a differential equation is given to you, what you are supposed to do is, first you have to convert that differential equation into polynomial form. And if there are any fractional powers, then you have to remove them. If there are any fractional powers, then you have to remove them. Also, if your differential element is trapped, if it's stuck, like it's stuck in the angle of log, it's stuck in the angle of sine, like you are not able to free it, then also degree will be not different. So we'll practice some questions based on these concepts. Okay, so what I'll do is, I'll first find the degree and order of these differential equations. Okay, are you guys ready? Okay. So what is the order and degree in the first question? So the first question is d2y by dx2 plus 3 dy by dx plus 2y is equal to 0. So what is the highest differential used? This is the highest differential, right? So order will be 2. And degree? So what is the power of that? See, degree is, you cannot find degree before finding the order. Okay, so first you have to find the order. So order is d2y by dx2. Now you have to see only this differential element. Like, it might be a possibility, for example, what if the question becomes d2y by dx2 plus 3 dy by dx whole power 5 plus 2y is equal to 0. Then many students are confused. They say, sir, the order is 2 and the degree is 5. No, you don't have to look its degree. You don't have to look the highest power for a lower differential element. You have to see the highest power of highest differential element. So what is the power of this? Its power is 1. So degree will be 1 only. Degree is 1 and order is 2. Yes, this is the answer for the first question. Degree is 1 and order is 2. Now again, if we talk about second question. So d2y upon dx2 is equals to y plus dy by dx whole power 6 raised to the power 1 by 4. Alright, d2y by dx2 is equals to y plus dy by dx whole power 6 raised to the power 1 by 4. Now we can see that we are having a fractional power. Are you guys able to see that? We are having a fractional power. So we have to remove that fractional power first before finding order and degree. Or we can find order by not removing it also. But we cannot proceed for degree without removing it. Okay? So we can we can take the power 4 on both sides. So this will become d2y by dx2 whole power 4. It will be y plus dy by dx raised to the power 6. Okay, this is the question. So now any fractional power is not there, not present, because we have removed that. So order will be 2 and degree will be 4. Y order is 2 because d2y by dx2 is there, and y degree is 4 because you have to look for the highest power of d2y by dx2. So it has appeared only one time and the power is 4. Which question you are telling degree 1 and order 1? Parikshit. For which question you are saying that? No sir, wrong. Yes, it is wrong. Okay. See the third question now. What is the order and what is the degree? Everybody. Degree 1 and order 1. Yes. Because dy by dx is used only. So its degree is, its order is 1. Order is 1. And the dy by dx is having its power as 1 also. So degree will be also 1. And everything is fine here. Similarly, in the fourth question, d2y by dx2 is equals to x square plus 2xy dy by dx. Again, degree will be 2. Sorry, order will be 2, but degree will be 1. Because being used as a differential element. And its whole power is 1. So degree is 2 and, order is 2 and degree is 1. Alright, this thing is clear? We have solved this question, right? So d2y by dx2 will be y plus dx dy by dx raised to the power 6. This is not dx, this is y. We have just now solved this question. By taking the fourth power on both sides, it will become d2y by dx2 whole power 4. It is y plus dy by dx whole power 6. So degree is, order is 2 and degree is 4. Now you guys please try this one. What will be the order and degree of this question? Dy by dx plus y is equals to 1 upon dy by dx. See, what is the case here? Dy by dx plus y is equals to 1 upon dy by dx is there. Okay? We can write 1 upon dy by dx as dy by dx raised to the power minus 1. Can we write like this? Dy by dx plus y is equals to dy by dx raised to the power minus 1, right? But I have said this. Power should not be a fraction or a negative integer. So this is right now not the correct format. So we cannot proceed for degree. Okay. Rather what we can do, just multiply this dy by dx, send this dy by dx into the left hand side. So it will become dy by dx whole square plus y dy by dx is equals to 1. Now we can easily see that the order is 1 and the degree is 2. This is the answer. Got it, everybody? Everyone got it? Yeah. So if there is something like that, like 1 by dy by dx is there, so 1 by dy by dx is not allowed. Why? Because it is written as dy by dx raised to the power minus 1. And power should not be a fraction or a negative integer. So if 1 by dy by dx is there, what you can do is you can send that dy by dx to the left hand side. You can cross multiply. So I have done cross multiplication. Cross multiplication. Okay, second question. Find order and degree of the following differential equation. So the question is like e raised to the power d3y upon dx cube minus x d2y upon dx2 plus y is equal to 0. Any answers from your side? dy by dx cannot be in power. It should not be present in power. See, we are having e raised to the power d3y upon dx cube. Okay. So this is a problem. This is a problem. Why? Power of e. The problem is, see, it should be in a polynomial form. Just because of this power of e, this equation cannot be written in a polynomial form. So yes, order is 3. Why order is 3? Because we can see that d3y upon dx cube is there. This is there, right? So order is 3. That is for sure order is 3. But degree is not defined. Degree is not defined because we cannot write this differential equation into a polynomial form. Yes, very good. So degree will be not defined. Degree is not defined. Similarly, next question. Find order and degree of the following differential equations. Find order and degree of the following differential equations. Now it is log dy by dx. Now it is log dy by dx. It is ax plus by. Yes? Log dy by dx is equal to x plus by. Can we separate this dy by dx? Yes, we can separate this dy by dx. It can be written as dy by dx is equals to e raised to the power ax plus by. So it can be written as dy by dx is equals to e raised to the power ax into e raised to the power by. Yes? So it is a function of x comma y. It is a function of x comma y. So it is acceptable because we are able to release the dy by dx from any angle. It is not trapped. It is not stuck anywhere. So yes, we can define the degree and order both. Order will be 1 and degree will be also 1. Because it is can be written. It can be written in polynomial form. Are you getting these things? Okay. Now I have to solve this question. See, this question was there in IIT 2002. We have to solve this question. It's a very easy question. What is order and what is degree? Tell me. One plus 3 divided by dx. Whole power is 2 by 3. It is equals to 4 d3 by dx cube. So to remove this fractional power, what should we do? We should whole cube on both sides. So 1 plus 3 divided by dx whole square will be 64 into dy by d3 by dx cube whole cube. So this is the highest order. So order is 3. Yes, order is 3 and degree is also 3. Clear? This should not be the question. Okay. So now we'll officially start this chapter from this concept. So differential equation is clear to you. Order of a DE is cleared and degree of a DE is clear. So we have covered 3 basic points in order to begin with this chapter. Is there anyone who is having any sort of confusion till here? So is there a good to go to proceed? Because from now this chapter will be important. The level of questions will be a bit high. Okay? Okay. Formation of differential equations. So formation of differential equations means you have to form a differential equation. Okay, you have to form a differential equation. Now there are only 2 steps to form a differential equation. So I'll write that 2 rules are there. Rule 1. You have to differentiate the given function. Rule 1 is you have to differentiate the given function as many times as there are number of constants. Alright, suppose for example my curve is y square is equals to 4ax. So how many variables are there? How many constants are there? Suppose for example my square is y square is equals to 4x. You all know that it is a parabola. So y square is equals to 4ax constant. The number of constants I'm talking, Parikshit. How many constants are there? A is a constant, right? This A is a constant. Yes. So number of constant is 1. So you have to differentiate it 1 times. Okay. 4 is not a constant because okay, I'll see. There are 2 types of constant. Okay. Please pay attention. Arbitrary, absolute. There are 2 types of constant in maths that we will dealing with this in this chapter. Arbitrary constant and absolute constant. So absolute constants are numbers. For example, 4, 3, 2, 7 and so on. Okay, 3 by 2, 8 by 5. So these are absolute constants. Arbitrary constants are like the constant, those are a part of equation. For example, A, T, right? Like this. V, U, like this. So there are 2 types of constants. So I should rather write it as number of arbitrary constant. Arbitrary. Okay. So the first rule is clear. I'll be writing rule 2 also over here. Rule 2. Rule 1 says you have to differentiate the given function as many times as there are number of arbitrary constants. For example, y square is equal to 4x is the one curve that we have taken. So in that curve, number of constants, or I can say arbitrary constants, are 1. So we have to differentiate it one time only. Okay? Rule 2 says while forming a differential equation, make sure that no constant should be there in the equation. While forming a differential equation, make sure that there should be no constant in the equation. Okay, so first rule is you have to differentiate it as many times as there are number of constants, and then you have to eliminate all the constants while converting it into an equation. Now I'll give you one question, okay? So we'll see how this question is there. For example, question is the same question, y square is equals to 4ax. Form a differential equation. This is the question. Okay, so what is its solution? So first of all, differentiate it. So it will become 2y dy by dx is equals to 4a, right? Now what is the value of a? So y by 2 dy by dx is a. Yes? So just replace this. Y square is equals to 4 into a. The value of a is this. So y by 2 dy by dx and into x. So this 2 and 4 will again cancel each other. So this will become y square is equals to y dy by dx into x. So this and y will cancel. Y by x is equals to dy by dx. This is the differential equation. Got it? So where is the rule 1 and where is the rule 2? This first step is from rule 1. Rule 1. So how many times we have differentiated it? Only one time. Why? Because there was only one constant. And this is your rule 2. Like we have to replace the value of arbitrary constant from the first equation. Is this clear? Now we can start questions. Start solving questions. See, every family of curves has its own differential equation. The order of differential equation is always equal to the number of independent arbitrary constants in the equation of family of curves. This one is very important. For example, I am having y square is equals to x square a plus b plus cx. We can write it as ax square plus bx. Okay, so two constants are there, two arbitrary constants are there. So that means you have to differentiate it two times. Now if you are differentiating any function two times, that means you are reaching second order derivative, right? So ultimately number of arbitrary constants will become your order of differential equation. So this is a very special rule. Number of arbitrary constants will automatically become your order of differential equation. This is clear? And this is nothing, just rule number 1, and this is rule number 2. Is there any kind of doubts? Anything that you guys are not able to understand? Everything is clear? Can we proceed? Okay. Solve one question, okay, on your own. Very simple question. You have to just find the order. Let me see who answers it. Come on. That should not take that much of time. What will be the answer? The order of the differential equation whose general solution is given by y is equals to c1 plus c2 cos x plus c3 minus c4 e raised to the power x plus c5. D. 2. You are saying 2 is the order. Anybody else? Apart from Parikshit? Any else? Anybody else? See, it's a very good question because it is manipulative. C1 plus C2 can be written as any constant. Let's say A. See, if there are two constants, they can be added, right? If C1 is there and C2 is there, you can obviously add them, C1 plus C2. These are not variables. You can add the constants. So we can write it as A. Now cos x plus C3. This we can't add. This we can't add, right? Minus, again, C4 into e raised to the power x plus C5. This can be written as e raised to the power x into e raised to the power C5. Just multiply the C4 inside. So this will become minus C4 e raised to the power x minus C4 e raised to the power C5. And a cos x plus C3 is there. Okay. This much is clear. Why? Now see, E is a constant. Okay, the value of E lies between 2 to 3. So E is a constant. And C5 is also a constant. So you are raising a power of constant over a constant. So constant raised to the power constant is always a constant. So this entire thing will be a constant. This entire thing will be a constant. And it is again multiplied with a constant. So this entire thing now is a constant. I can call it as K. This is my variable because x is there, so I can't touch it because it's having a variable part. I can't touch this also. I can rather write it as B. So the final is y is equals to A cos B minus C4 e raised per x minus K. Anybody else? Got it? Got this thing? What is the order? First is this variable. Wait. Okay. Wait. I've made a very small calculation mistake. Yes. See, please note that y is equals to A cos x plus C3 was there. So this is a one constant with us. Okay, so this is A cos x plus C3 and minus C4 into this e raised to the power x plus e raised to the power C5. E raised to the power x. Okay, we have included e raised to the power x. Yes, we have included. Sorry. E raised to the power x we have included and e raised to the power 5 we have included. Right? So this is a constant. This whole is a constant. Yeah. So yeah, this is an absolute. This will become an absolute constant. This will become an absolute constant. This will not be an arbitrary constant. It is an absolute. So what are arbitrary constant? A, C3 and C4. A, C3 and C4. So order will be 3. Yeah, this was the main point. Okay. So did you guys notice like what is the manipulation that I've used? Why I'm not taking this whole thing as a constant C4 into e raised to the power C5? Because all these, when we combine all these things, this will become an absolute constant, and we don't have to count absolute constant in order to find the order of a differential equation, right? We have to find only arbitrary constant. So these are arbitrary constants. 3. So the, 3 is the answer. Clear? Okay. Okay. So now we have to try this question. So the differential equation satisfied by the system of parabolas y square is equal to 4ax plus a is, we have to find the differential equation only. So just follow the 2 rules and you will get the answer. So I'll do this for you guys. Okay. So y square is equal to 4a into x plus a. This is the curve, right? And we have to find the differential equations. It's a question from JEE Main 2021. So first we have to follow rule number 1. So how many constants are there? Only one, a. So we have to differentiate it one time only. So just differentiate it. So 2y into y dash, right? Derivative of y is dy by dx. I can call it as y dash is equal to 4a. Yes. So what is the value of y into y dash is a. The value of 2a, sorry. So the value of a will be y into y dash by 2. This will be the value of a. Rule 1 is cleared. Now what is rule 2? Rule 2 is again rewrite this equation. Rewrite this equation as y square is equal to 4a, not just a. Rather of writing a, you should write y into y dash by 2. Y dash by 2 into x plus a, y dash by 2. Okay. So see, this y and y get cancelled. This 2 and 4 will get cancelled. It will become y is equals to 2y dash into x plus y dash by 2. Are you getting the things? So y is equals to, just multiply this inside, so it will become 2y dash x plus this 2 and 2 will cancel. It will become y dash whole square. Yes? Sir, in second step, how 4a came, sir? In second step, how 4a came? This is a constant, beta. 4a is a constant, right? So you have to take this constant outside. You're differentiating it, right? You have to take this constant outside and differentiate this part only. So it is 4a into 1, basically. Yeah. Okay, so now this is the answer. So now replace y dash with dy by dx. So this will become y into dy by dx whole square. Y into dy by dx whole square, right? Plus 2 dy by dx into x minus y is equal to 0. This one is my answer. Such an easy question. So what is the answer? Y dy by dx whole square plus 2 dy by dx into x plus 2 dy by dx into x minus y is equal to 0. In this is the plus y and this is minus y. This one is plus y and this one is minus y. So C is the answer. Got it? Have you guys noted this question? Done. Okay, so now try this one also. The difference between degree and order of a differential equation that represents a family of curves given by y square is equal to ax plus root a by 2. Again, how many constants are there? Number of arbitrary constants is 1. Number of arbitrary constants is 1. So you have to differentiate it only one time. Please try to do this question on your own. Meanwhile, I'll go get some water from you. Yes. So has anyone reached the answer? Are you guys still trying? The difference between degree and order of a differential equation that represents the family of curves given by y square is equal to a x plus root a by 2. First we have to write the equation y square is equal to a into x plus root a by 2. Since we have only one arbitrary constant, so that means we have to differentiate it one time only. So it will become 2y into y dash is equal to a into x plus root a by 2. That is only this, right? So this will be only a. So we have the value of a as a is equal to 2y y dash. Now just put this value over here. So it will become y square is equals to a, that means 2y y dash into x plus root a by 2. So root 2y y dash, root 2y y dash by 2. Okay. So since we have a one problem over here, this y and y will get cancelled. So it is y is equals to 2y dash into x plus root 2y y dash by 2. So we are having our differential element inside the root. Okay, just see this. We are having y dash inside the root. So that is not allowed because we cannot find degree if something like this has happened. So what we are supposed to do? So we can remove this like y minus 2y dash x. Okay, and this will become, see, what you are supposed to do is just multiply this and multiply this. So y is equals to 2y dash x plus y dash into 2y y dash. Alright. Now you can bring this term over here. So this will become y minus 2y dash x. It is y dash into 2y y dash again. Now you can whole square this equation. So on squaring both sides, So y minus 2y dash x whole square is equals to y dash square into 2y y dash. So this entirely will become y minus 2y dash x whole square is equals to 2y y dash whole cube, because this is power 2 and this is power 1. So this will be power 3. Now just replace your y dash with dy by dx. So this will become y minus 2 dy by dx into x whole square is equals to 2y dy by dx whole cube. Now you guys are able to spot the order and degree. Since the highest differential element used is dy by dx only, so that means order is 1. But it is having its degree as 3 because the highest power of dy by dx is 3. So order is 1 and degree is 3. So what is the difference of 3 and 1? Difference is 2. Order is 1, degree is 3. So difference will be 2. So 2 is the answer. And now don't write minus 2. If you talk about difference, it means, obviously it means greater minus 1. So whoever of the two is greater, just put that. Try to copy this question. Let me try to put that on a single page. Yes. Okay, so this is the entire question. So alright guys, we'll be taking a very short break. So I'll be back after 10 minutes, okay? Meanwhile, note this question. Okay, everybody, the break is over. The class is resumed. Quickly turn on your camera so that we can proceed. So tell me, until here, everything is clear? Is there any sort of doubt, query, confusion till here in any of the question? We can start, right? Okay. Okay, now this one is very interesting question as it is, you can clearly see from JEE Advanced 2015. It's a multi-correct question. So consider the family of the circles whose centers lie on the straight line y is equals to x. If this family of circle, okay, I'll give you the diagram also for that. The question is saying to me, that there's a line which is y is equals to x. So we all know that this is the equation for y is equals to x. Okay. Now any point, let us take this point. So this one is supposed to be the center. So we have to draw a circle. So let us say this is the circle. Okay. So we don't know the radius. Also we don't know the coordinates of center. So we can take coordinates of center for our reference as a comma a. Okay. We can take a comma a as center. And we can take r as the radius. We can take a comma a as the center and r as the radius. Now why we have taken a comma a? Because y is equals to x. Got it? Y is equals to x. So if you are talking about like abscissa. So if abscissa is a, then ordinate will be a also. Right? So a comma is supposed to be the center and r is the radius. So what will be the equation? See, in questions like JEE, like if the question is from JEE Advanced, it will directly tell, it will not directly tell you anything. Okay, it will say, like just read the question, consider the family of all circles whose centers lie on the straight line. But nowhere the equation of circle is given. Because that is your job to find the equation of circle. In order to begin with the question, first you are supposed to find the equation of circle. What is the equation of circle? So it is, we all know x minus a whole square plus y minus b whole square and is equals to r square. Okay, x minus a whole square plus y minus b whole square is equals to r square. But yeah, but here the center is a comma a, so it will again, the final equation will be x minus a whole square plus y minus again a whole square is equals to r square, as the center is a comma a. So this is when a comma b is center. Now since we are having this equation, so we have to form the differential equation from this equation. For this function we have to form a differential equation and then we can compare our differential equation with this. P y double dash plus q y dash plus 1 is equals to 0. Then we can easily find the value of p and q and the answer will be there. So now would you like to try this? Should I tell you directly or you will be trying it first of all? Please mention in the chat whether you want to try it or not. 2 minutes, you will try. That's very good, Spirit. You can try it on your own, okay? So we have to start our question from here. Just form the differential equation for this curve and like 90% of the question will be solved. Let me know how many times you have to differentiate. How many times you have to differentiate? 2 times. Why? Because we can clearly see there are 2 arbitrary constants, A and R. So you are supposed to differentiate it 2 times. And just replace the values of A and R. Try it and let me know. Yes, what happened? Is there anybody that has got the answer? Or should I try it on myself? Okay, see. So differentiation will be 2 of x minus a plus 2 of y minus a into y dash is equals to 0. Okay, this is the first equation. Now you have to differentiate it again. So what will be the derivative? So 2 of x minus a, 2 plus, now see, we have to take 2 as common. Now y minus a into y dash. So how we are supposed to differentiate it? We have to use UV, product rule over here. So we take y dash as we have to take y dash as common, and then derivative of y minus a, that is y dash minus, sorry, y dash minus 0, yes, plus, now we have to take y minus a and then we have to write derivative of y dash, that is y double dash is equal to 0. Okay, also we can take 2 as common from the entire equation, so this will become 1 plus, now what is this? This is y dash whole square plus y into y double dash minus a into y double dash is equal to 0, and this 2 can be sent to the right hand side, so this will be all will be 0. This thing is clear? Okay, so students, those who have turned their cameras off, quickly turn on your cameras, otherwise I'll kick you out of the session. Yes, good. Alright, this thing is clear? Now what is the second step? What is the rule 2? Now all of you are supposed to find the differential equation. Step 1 was there, we have to differentiate the function twice. So we have differentiated it twice. Now what we are supposed to do? We have to eliminate the values of constant. Okay? So we can do this from here. Like, see the equation 1. Only this thing is there, x minus a and y minus a. You can replace the value of a with this. Okay, let me write it again. So this is 1 plus y dash whole square plus y into y double dash minus ay double dash as equals to 0. Got it? Yes or no? Tell me, anybody still doing it? Or you have got the answer? No, sir. So please try. Okay, I am rewriting the equation first. Okay, see. 2 into x minus a. 2 into x minus a. Plus 2 into y minus a into y dash. Y minus a into y dash is equals to 0. Can we take 2 as common? We can take 2 as common and it will be sent to right hand side, so it will again become 0. Now, what we are left with? We are left with x minus a plus y into y dash minus a into y dash, right? So we can take a as common from these two terms. Okay, so x plus y into y dash. If we take minus a as common, so it will become 1 plus y dash equals to 0. So it is x plus y into y dash is equals to a into 1 plus y dash. So what is the value of a? The value of a is x upon x plus y into y dash upon 1 plus y dash. This is the value of a. From the first equation itself, we have obtained the value of a. Now only we have to replace this value of a in the equation number 2. So what was the equation number 2? So equation number 2, as you can clearly see, it is, first I have to draw a line. It is 1 plus y dash whole square plus y into y dash, y double dash, minus y double dash times a. Now rather writing it as a, I will write the value of a. So x plus y into y dash, x plus y into y dash upon 1 plus y dash, upon 1 plus y dash. Now you guys can solve it. So multiplying it by 1 plus y dash, multiplying entire term with 1 plus y dash. So this will become 1 plus y dash plus y dash whole square into 1 plus y dash plus 1 plus y dash into y double dash, and minus, if you multiply this with 1 plus y dash, it will become y dash, y double dash, x, and minus y double dash into y. Now again expanding it. So expand it, it will become 1 plus y dash whole square plus y dash whole cube. Because y dash whole square is there and plus y dash into y dash whole square, it will become y dash cube. See, it will see a little bit confusing. But believe me, it is very easy because you have to try it on your own. When you will try it on your own, the answer will be there. This is again y into y dash plus y into y double dash. Okay? Minus y double dash x and minus y double dash y is equal to 0. Now what are the terms that will cancel? y into y double dash, y into y double dash. This will cancel. Now we have to compare it with what was the initial question from which we have started solving it. We have to compare it with py double dash plus qy dash plus 1 is equals to 0. That means we must have a plus 1 term and a 0. Okay? And we have to separate y double dash and y. So we can do this from here. So this one we have to keep it as 1 is equals to 0. Now see y dash. We can write y dash plus y dash whole square plus y dash whole cube is also there. Plus y into y dash into y double dash and minus y double dash x. Okay, so we can take y double dash as common. So y double dash is common. So what will be there? So y double dash taken out. If y double dash is taken out as common, so inside it will be y into y dash and minus x. Got it? Because only these two terms are having y double dash. Plus rest of the terms. What are the rest of the terms? The rest of the terms are y dash plus y dash whole square plus y dash whole cube. Okay, and plus 1 is equals to 0. Now we can compare it with p y double dash plus q y dash plus 1 is equals to 0. So on comparison we can get the values of p and q. Find the values of p and q. Clear? Question is clear to everyone? You want to write it?